Hey there, math hoppers! In this video lesson, we will learn about identity and inverse matrices. Let's start with identity matrices. All right, we're going to take a trip in the Wayback Machine and remember back to elementary school when we learned all those cool multiplication facts. We learned that if we multiplied any number by 1, the value of that number remained the same. So we learned that 1 times 5 was equal to 5. 1 times -2, yep, it still worked with negative, so we got -2. 1 times n, yes, it worked with variables, we got n. 1 times x cubed, yes, it worked with variables raised to various powers, we got x cubed. And eventually our teacher threw the identity property term at us, and we learned that this was called the identity property of multiplication because multiplying by 1 kept the identity of what you were multiplying the same. All right, well, this same property exists with matrices. Now, it's not as easy as the number 1, but we do have an equivalent to the number 1 with matrices, and that is the identity matrix, and it is denoted with a capital I called matrix I or the identity matrix. The identity matrix is a square matrix. It has ones on the diagonal from top left to bottom right, and all the other entries are 0. So you'll see it denoted with this I sub n because it's a square matrix. So we could have I sub 2, which is the 2 by 2 identity. We could have I sub 3, which is the 3 by 3 identity. And if you don't remember, a square matrix is simply a matrix that is order m by m. So it has the same number of rows as it does columns. So let's look at a few. The I sub 2 identity matrix for a 2 by 2 matrix simply has diagonal of 1s, top left, bottom right, 0s everywhere else. Then we have the I sub 3, the identity matrix for a 3 by 3 matrix. Again, diagonal of 1s, top left, bottom right, 0s everywhere else. And since this is the equivalent of the identity property of multiplication, it should make sense that multiplying a matrix by its identity matrix results in a product equal to the original matrix. And that's really cool. But what it looks like in your math textbooks probably looks like this. It's got this mathy language to it. It says matrix I times I sub n. This just means some matrix A times its identity matrix equals A. So you're going to multiply matrix by its identity matrix and get the same thing. Then, if you multiply some identity matrix by A, assuming this is like a 2 by 2 and A is a 2 by 2, you're going to get the same matrix. What's cool about this is it says that when you're multiplying by the identity matrix, multiplication is commutative. And we know that multiplication in matrices isn't commutative. There's only really 2 rare instances where it is, and this is one of those. So that's kind of cool. All right, let's talk about inverse matrices because they're really closely related to identity matrices. So far, we've added matrices, subtracted matrices, we've multiplied matrices. However, we don't divide matrices. And you might be thinking, great, I don't want to do that anyway. But instead, we use inverse matrices. Remember that multiplying a number by its inverse is the same as dividing by that inverse. So for example, you could, instead of dividing by 2, you could multiply by the inverse of 2. So 10 times 1/2 is 5, and 10 divided by 2 is 5. So multiplying by 1/2 and dividing by 2 are the same. That idea exists in matrix multiplication or matrix operations, if you will. So remember this property, this 1 over A times A equals 1. We learned that 1 over A was the inverse of A. In the example I just gave, remember that 1/2 was the inverse of 2. And when we first learned it, we called them reciprocals. And then we learned the inverse property. If we took the product of a number and its inverse, we always got 1. Well, this is the property that exists with matrices, except the product isn't really 1. It's the matrix equivalent of 1, which is the identity matrix. So if you're going to multiply a matrix and its inverse, you will get the identity matrix because the identity matrix is the equivalent of 1. Let's look at what this looks like symbolically. We take the inverse matrix. Remember, the universal symbolism for an inverse is this -1 up in the exponent, even though it has nothing to do with exponents. This A superscript -1 is what we call, or it's the symbolism for the inverse of matrix A. The identity matrix is simply capital I, very easy. And so the property exists that if you multiply a matrix A by its inverse, you get 1. But you don't really get 1. You get the matrix equivalent of 1, so you get the identity matrix. So matrix A times its inverse gives you the identity matrix. Also, if you take the inverse matrix and multiply it by its inverse A, you also get the identity matrix. This is the other time where matrix multiplication is commutative. Remember, this is only true because we're multiplying matrices by their inverse. Matrix multiplication is not normally commutative. All right, so what will you be asked to do? Well, you could be asked to show that two matrices are inverses, right? Remember, when you multiply an inverse or a value by its inverse, you get 1. So if we want to show matrices are inverses, we should multiply them and get the matrix equivalent of 1, which is the identity matrix. So let's show that matrix B is the inverse of matrix A. Here's matrix A. It's a 2 by 2 square matrix. Here's matrix B, a 2 by 2 square matrix. Remember, if these two matrices are inverses, the product will be the identity matrix, that diagonal from top left to bottom right of 1s. So let's go over matrix multiplication in case you forgot. Multiplying A times B. To get the entry in the top left position, we have to take top row, so the top row of A, by the left column of B. Remember, top left means top row, left column. We multiply the corresponding entries, so the first entry, -1, times the first entry, 1, plus the second entries multiplied, 2 times 1. So we get -1 times 1 plus 2 times 1. Perfect. Let's move on to the top right. Top right means top row, right column. -1 times -2 plus 2 times -1. Moving on, bottom left means bottom row, left column, -1 times 1 plus 1 times 1. Great. Bottom right means bottom row, right column, -1 times -2 plus 1 times -1. Let's clean this all up and see what we're adding. So in the top left position, we go from -1 times 1 plus 2 times 1 to -1 plus 2. Then the top right, we get 2 plus -2. Bottom left, we get -1. That's -1 times 1 is -1 plus 1 because we had 1 times 1. Bottom right, we get 2. -1 times -2, remember, is positive 2 plus -1. We simplify this, we're going to see that we do get 1s on our diagonal from left to right, and we get 0s everywhere else. So it looks like the product of A times B gives us the identity matrix. All right, let's try the product of B times A. So remember, top left, you're going to do top row times left column. So 1 times -1 plus -2 times -1. Remember, top right is top row, right column. So 1 times 2 plus -2 times 1. And moving right along, you see the pattern. Let's clean this up. B times A, actually this should say B times A because that's what we're following here. -1 times 1 is -1. -1 times -2 is positive 2. 2 times 1 is 2. -2 times 1 is -2. -1 plus 1, that's what you get when you multiply 1 times -1 plus -1 times -1. And the last entry here is 2 plus -1. So cleaning that all up, we look and see that B times A does in fact give us the identity matrix. So since A times B does equal 1, the identity version or the identity matrix, the matrix version of 1, and B times A is equal to 1, the identity matrix, the inverse of B is A and the inverse of A is B. So these matrices are in fact inverses of one another. Perfect. Now you might be thinking, how in the world do we calculate an inverse matrix? All right, good news. It is really easy with a 2 by 2, so we're going to start there. And a 3 by 3, we're going to let the calculator do the work, and we're going to show you how to do that. So let's start with a 2 by 2 matrix. Let's call matrix A, and let's name the entries A, B, C, D. So top left, top right, bottom right. because we're just going to give you the rule for the inverse. I know normally we go through why the rule works. This time, in this instance, it's really best to just kind of commit this rule to memory. So the inverse of matrix A is equal to 1 over AD minus BC. So AD minus BC simply means multiply on the diagonals and subtract. So top left to bottom right, multiply A times D, subtract C times B or B times C. Okay, and then we're going to multiply this by what I like to call the matrix reimagined or the matrix rearranged. A and D are going to switch places, and B and C are going to switch signs. If they're negative, make them positive. If they're positive, make them negative. Now, you won't see this AD minus BC in your textbooks, and that's because it has a special name. AD minus BC is called the determinant of a matrix. And I know the name seems weird, but it's called the determinant because it determines if an inverse exists. Notice that it is in the denominator of this fraction. Therefore, if the determinant, AD minus BC, is equal to 0, then the inverse matrix doesn't exist, simply because, remember, we cannot divide by 0. No, it is not okay to divide by 0. All right, so the rule for an inverse matrix, that probably is how it looks in your textbook, says 1 over the determinant times this rearranged matrix, dA on the corners here from left to right, and then negative B and negative C. BC change signs, and A and D switch positions. Okay, so if possible, let's determine the inverse of matrix A. Given matrix A is 3, negative 1, negative 2, 2. Let's first figure out what the determinant is. So 3 times 2 is 6, minus negative 2 times negative 1 is 2. So 6 minus 2 is the determinant, and then we're simply going to switch places here, AD, and switch signs here. So this is what this looks like. We get 1 over 6 minus 2, and remember, A and D switch positions, so you get 2 where the 3 was and a 3 where the 2 was, and this negative 1 and negative 2 switch signs, so we simply have positive 1 and positive 2. Let's clean that up. We know that 6 minus 2 is 4, so this gives us 1/4 times this matrix. Now, I have seen textbooks where you leave it like this, or you could simplify. You can multiply every single entry by 1/4, which really just means dividing each entry by 4. So if this answer doesn't match what your teacher's looking for, or maybe what's in your book, it's because they took one extra step and simplified it, multiplied everything by 1/4. You get 1/2, because that's what 2 over 4 is, 1/4, 1/2, because that's what 2 over 4 is, and then 3/4. And you're done. We are going to use inverse matrices so much more when we solve matrix equations and when we solve linear systems with matrices. So for right now, you just need to know how to determine an inverse for a matrix if it exists. But later we will use these a lot. All right, inverse for a 3 by 3 matrix. Good news, bad news. Bad news is it's so difficult to do. It's a little tedious and time consuming. Good news is because of that we use a calculator. So calculating the inverse of a 3 by 3 matrix by hand is super tedious. It involves minor matrices and cofactors, and there's a whole separate lesson or video lesson just on that. So for now, we're going to use our TI graphing calculators. So to calculate the inverse of matrix A, given this matrix A right here, 3 by 3 matrix, we are going to take out our graphing calculators. We're going to hit matrix. Remember, matrix is that second function and the x with the negative 1 in the exponent position. Then we'll hit edit, enter 3 by 3. You have to put 3 by 3 and enter your elements. So here's what it looks like. When you hit matrix, edit, enter, it's going to ask you, you usually pick matrix A because it's the first one. You have to go ahead and change the dimensions. Type in a 3 here and a 3 here, and then you have to go ahead and enter all of the actual entries. So 3, 0, 2, 2, 0, negative 2, 0, 1, 1. All right. Once you do that, hit quit, then go back to matrix. Choose whatever matrix this was. It's likely matrix A. So choose matrix A, and then hit the inverse X button and hit enter. And so it's going to say, oh, you want the inverse of matrix A? Here it is. Now, most teachers will want you to calculate this by hand. Maybe they'll say use your calculator. Either way, they usually like the answers or the entries as fractions. So just hit from this screen, hit Math, then the drop-down fraction, and it will change your answers to fractions. And this will be the inverse of matrix A as fractions. These are equivalent. You notice that 2/10 is equal to 1/5. This just puts it in fractional form for you. So that's it. Those are identity and inverse matrices. 2x2 inverses, absolutely you calculate by hand. A 3x3 inverse, for now we calculate using our TI calculators. We will do a video later on how to do it by hand. If you have any questions, anything wasn't covered in here, you should be subscribed to our YouTube channel. That's where you send us those problems, and I will make you a custom math solution. Until next time, Math Hoppers, take it easy.